Welcome to another lesson with Dr. Hill. Today we're talking about alkenes, the unsaturated hydrocarbons with double bonds. So in order to understand those, we looked at the models in our last lesson. What we're going to do today is we're going to look at the board and we're going to see how we draw these structures and talk about some of their properties and where they come from. So let's have a look at the board. And here you see I've written some quick notes. Unsaturated hydrocarbons. They're unsaturated because you can break those double bonds apart and you can squeeze in more atoms into the molecule. We're looking today at the alkenes, A-L-K-E-N-E-S. They're made by cracking alkanes. Alkanes you can get in very large sizes, and you break them all up by cracking them. That's a process. You can look it up if you wish. They have a double bond between at least two carbons. So these things have, that's not very well written, these things have the E-N-E ending, okay? And the simplest one of them is, we'll just draw it. Remember, it's just two carbons. You can't have a double bond between one carbon because there's only one carbon. So we can do this, and there's our double bond between our two carbons. Because you have used up two bonds from each carbon in the double bond, you can only get one hydrogen onto each of the other two bonds. And so our formula is going to be C2H4. Okay, and that means that the general formula for these structures, as long as they only have a single double bond in them, is going to be CnH2n. Okay, so the number of C's multiplied by 2 will give you the number of hydrogens. All right. Now that's the simplest one. This one, if you're going to write the structural formula, you might the condensed structural formula, you might want to write it like this. You've got CH2, that's this, and we have CH2. Now we know because there aren't three hydrogens in each of these carbons, there has to be a double bond between the carbons. So with the condensed structural formula, there's a little bit of working out to be done by the person who writes it down. But the good thing about that is you can put it into a line of text in a text document, which you can't do with this. Okay, so we have that. Now, I did promise to show you that there is another way of drawing molecules that you've probably seen on the internet doing some practice problems and things like that. And that's using the line angle system. Now, we don't need that for National 5 chemistry, but it's worth knowing because it's a good way to do revision. So all we have here is we have a single bond, well, a double bond between two carbons, and the structure, believe it or not, is just these two lines done at an angle. All right, we can there's a carbon at one end of the line and a carbon at the other end of the line. Now I'm going to show you another structure, CnH2n. So let's have a new structure. We're going to take this is the two carbons, and this is ethene. Okay, now ethene and butene are, ethene and propene are easy enough. They've only three carbons. You can only have individual structures for those, but for more alkenes with more carbons, the double bond's going to appear in different places, so they have to be named accordingly. So let's take a pentene type molecule and we'll have a look. So if I'm going to do that structure here, I'm going to take a C and a C and a C and a C and a C. I'm just going to put 5 carbons in to make it simple, and then I'm going to put my double bond there. So what have I got? 5 carbons, and the rest are going to be hydrogens. Okay. So here I can have only one extra hydrogen because the carbon's got a bond going this way, a double bond going that way, and one bond coming to the hydrogen. Then I've got my H here and my H here, and I've got my H here and my H's. Okay, so that's all the atoms I can put into this structure. Now, as we've said before, you can break these double bonds apart and get more atoms into the structure. If you break one of these bonds off, you can add more hydrogen to the structure. And that will release a bond on each of these carbons, and each of these carbons, for example, and we get an extra 2 hydrogens into the structure, and we'll make an alkane. Right? That's simple enough. That's called hydrogenation. We'll talk about the reactions of alkenes very shortly, addition reactions. But let's have a look at this. What are we going to call this thing is the first critical issue. Now there's 1, 2, 3, 4, 5 carbons, so it's going to be a pentene. ENE and pent for 5 carbons. But the problem here is that we have to indicate where the double bond is, because the double bond could be here, and which is where it is in this diagram, or it could be here, and these would be separate isomers of the pentene. So we have to give the pentene 2 different names. We can have if it's either here or here, it's going to be the same structure, because you could just turn it over. If it's either here or here, it's going to be the same structure, you can just turn it over. So let's name this one. So it's going to be certainly going to be pent. Now we have to put a line in, and now we're going to indicate the number of the carbon, the smallest number of the carbon that contains a double bond. So I could count from this end, 1, 2, 3, and that would be 3 there, or 1, 2, and it would be 2 here. So it's pent 2 ene. Okay, that's the name of that alkene, pent 2 ene. Now, if I'm going to draw it using the line angle structure, I've got 1, 2, 3, 4, 5 carbons, and all we do is we go 1, 2, 3, 4, 5, like that, and then we put our double bond in. Our double bond's going to go there. Okay, and that's it. So if we see, I guess you didn't see me draw that, I'll do it again. So 5 carbons, we start off with a line counting 1, 2, 3, 4, 5, and then the double bond on the second carbon. So this is carbon 1, 2, 3, 4, 5. So the line angle diagram for structure is very, very simple. You don't draw the hydrogens, you don't even write out the letters. The line represents bonds, and the angle between the lines, or the start of a line, represents a carbon atom. All right, so that's an introduction to the alkenes. We'll look at some more different structures of alkenes in detail in another lesson, because we're going to look at writing our structural formulae. Let's just, before we go, let's do the condensed structural formula for this thing, pent 2 ene. So it's CH3, CH, CH, CH2, and CH3. Now we're going to look at how to draw these with branches in our next lesson. All right, so thanks for listening. I hope that was useful to you in learning about your alkenes. And what we're going to do is we're going to go on to drawing more examples in our next lesson, and looking at branching structures and how we name those. So it's very simple and just formulaic. So we'll do that next time. Thanks for listening. Bye now.